This summary sheet talks about linear functions, absolute value functions, quadratic functions, and exponential functions. We go through slope intercept, point slope, vertical lines, horizontal lines, and then writing equations from graphs. All linear functions do not have absolute value symbols or any exponents. The first thing we're going to look at is slope intercept form, where it's y equals mx plus b, where m is the slope, rise over run, and b is the y-intercept, where it crosses the y-axis. So looking at our first example, y equals negative 3, x plus 4. Negative 3 is our slope, and 4 is our y-intercept. So we plot the y-intercept first. So we take our 4, that is our point, 0, 4, and we plot that, and then we use our slope, negative 3, and I always put that over 1 so we know what our run is, to go down 3 to the right 1, down 3 to the right 1, and use a straight edge to connect our points. Point slope form is y equals m times x minus an x value plus the y value of a particular point on the line, but it doesn't have to be the y-intercept. M, the coefficient of x, is still the slope. Looking at our example here, we have no number in front for m, so we can put a 1 in there as a placeholder. So our slope is going to be 1 over 1, and our point is the opposite for the x-coordinate and the same as the y-coordinate when looking at our equation, and that is because of this negative in our equation. So looking over here, I see a negative 2 in my equation, which means my point is positive 2 for x, and the outside of our brackets is a minus 1, and that stays the same. So my y value is negative 1. So 2, negative 1 is my starting point. From that point, I am going to go up 1 over 1, up 1 over 1, and plot a few points there before getting my straight edge. When I have only one variable, it is a special case. So when I have the case of x equals a number, as in x equals negative 3, I want to go to my x-axis and plot a point at negative 3. I need to think about where are the x values, always negative 3, and that's going to be along this vertical line right here. And vertical lines have all rise but no run. They don't go right or left at all. And any number divided by 0 is undefined, so our slope is undefined. The line does not cross the y-axis, so it has no y-intercept or no b value. You might think of it as having an x-intercept at negative 3, 0 instead. Our other special case is y equals a number, as in y equals 3. So you go to the y-axis and plot the point 3. And it's the line that has all y values of 3, which is the horizontal line through y equals 3. In this case, it is a graph that has all run but no rise. No rise would be 0, and the run could be any number, and 0 divided by any number is 0, so our slope is 0. Our y-intercept would be 3, which you could write as 3 or as the ordered pair 0, 3. Absolute value functions will always have these straight brackets as their key identifier, and the equation looks very similar to point slope form except for the straight brackets, and it behaves the same way, where instead of any point we have the vertex, but it's the opposite inside the brackets, the same value outside the brackets. So looking at this equation right here, I see plus 4 inside the bracket. That means my x spot is minus 4. Outside, I see plus 5, so I keep that sign the same for a positive 5 for my vertex. And so I graph that at negative 4 for the x and 5 for the y. The a value is the coefficient of x here, and it tells us if we open up or opens down. And when I look at my equation, I just see a negative. Remember, we can put a 1 in there, so our A value is -1, which tells us that we open down, and we're going to graph that with a plus or minus 1 over 1. So from my vertex, I am going to go down 1, right 1, but I'm also going to go down 1, left 1. And I keep going in both of those directions to get this V-shaped graph. For quadratic functions, you're always going to see an exponent of a 2 somewhere in there. In our general form right here, again, behaves very similarly to point slope form and absolute value form. Opposite for the value that's inside the brackets for x, same sign for the value that's outside the brackets, the y value. Looking at our value right here, we can see that our vertex should be, if I have a -3 in my equation, I'm going to have a +3 for the x spot, and if I have a -3 on the outside, it's going to stay -3 for the y spot. Let's plot that point. X is 3, y is -6, so that's down here. And then we have to decide if it opens up or down, which again we do with our A value. Our A value is a +2, so that means we open up. And we have to look at jumps. It does not have a constant rate of change, so we are looking at our first jump is going to be the A value, or 2. The next jump is 3 times the A value, or 3 times 2, which is 6. And then if we have room for a third jump, it's going to be 5 times the A value, or 5 times 2, which is 10. So what that means is from my vertex, I'm going to go up 2 to the right 1, and up 2 into the left 1. And then from those points, I'm going to go up 6 into the right 1 and do the same thing in the other direction. That is all I have room for, and I'm going to make a nice curve. For exponential functions, it will always have an exponent that is a variable, and when I look at my equation, y equals 1/2 raised to the x power, that's what makes it exponential, -3. The first thing we do is we look at the asymptote. That's if there's something being added to the equation. That's our floor. That's going to be the bottom of our graph. Looking at our equation, I see a -3. That means my asymptote is y equals -3, and I'm going to make a dashed line through y equals 3. From there, I want to find my y-intercept. So what happens when x is 0? We can plug that in to be 1/2 raised to the 0 power -3. If we plug that into our calculators, we get -2. That's this value right here. It will always be 1 up from our asymptote. Is this growth or decay? To find that, I look at what is being raised to the x, and I see 1/2. That is less than 1, a fraction less than 1, so I know my graph is going down, which means my tail is over here, and I can just put that in. So that means I basically know what is happening on the positive part of the graph, and so I need to figure out what is happening on the negative part of the graph, so I can plug in some negative values to find that out. Or I can use the idea of the multiply here to use the pattern. I'm going to plug these values in to the x spot of my equation. So 1/2 to the -1 power -3. I can plug in -2 and -3 in my calculator. I get these values when I plug them in, and now I'm going to plot them. So -1, -1 is right here, and then I have -2, +1, and -3, +5 right here, and I'll continue my curve. For writing equations from graphs, you're just working backwards, and you still need a point and something about the rate of change, so either the A value or the M value. For a quadratic, which is this because it's a curve, or an absolute value, you have a vertex, so we're going to plot that point or record that point, and that's right here. And that point is -5 because that's on the x-axis, and on the y-axis we're at 7. So -5 comma 7, and then between the first jump, like that's what we're basically finding here, you're going down 3, so that's our a value. So I can just plug that into our equation. Y is equal to my a value, which is -3, x, and then remember that it needs to be the opposite. So if I have a -5 here, I'm going to have a +5 in my equation, and I have to have a square if it's a U-shaped curve, if it's quadratic, and then I see a +7, so I'm going to have a +7 in my equation. For a line, you can write it in slope-intercept form or in point-slope form. We're going to do both. I can see that my slope, my rise is 3 and my run is 1, and my graph is going down, so I know it is a negative slope, and my y-intercept is here at 5. So I can write this as y equals -3x plus 5. Now, if I have to give this in point-slope form, I can use that same point. I need to think of it as an ordered pair, and it would be -3, and it would be x minus 0, because that's the x spot, and then plus 5, because my y spot is +5. I could write the equation for any of the points on my graph. This point right here is 1, 2, and if I was writing that equation, it would be y equals -3, and then it would be x minus 1, because I have a +1 right here, and then plus 2, because I have a +2 here. If I'm looking at this point is 2, -1, and to write that in point slope form would be y equals -3, because it's the same slope, and then x minus 2, because it's a +2 in the point right here, and then minus 1. Any of these equations would accurately represent this line right here.